Yeah, thank you very much for the intro. It seems like I'm the last speaker of this day, and I'm the only one between you and the weekend, in Europe at least. For me, the day has just started here. And yeah, let me give you a quick introduction of myself. I'm a principal research staff member at IBM Research in Cambridge, in Massachusetts here at the East Coast, and I lead the AI interaction team, an interdisciplinary group of HCI and machine learning researchers. We have designers, social scientists, psychologists, and also software engineers on my team. And let me just see, I can maybe make this full screen. View, toggle full screen. A moment. There you go. That should be better, right? So the research that we are doing here is at the intersections of user experience and artificial intelligence. And in my talk today, I'm going to talk about the research we do on human-centered AI. And in particular, I'm framing the content I'm presenting today here in the context of automation through AI versus collaboration with an AI system. So thanks again for having me here. I hope you will learn something new and also feel equipped with new resources for designing, building, and studying your own human AI systems. It seems like there were, unfortunately, I couldn't join all the talks, but I saw some of them. There were some interesting talks already that provided very interesting insights on that. My perspective is a little bit more a research perspective on things. So, as the name of my talk suggests, our team cares deeply about taking a user-centric perspective when developing AI systems, and I wanted to kick this talk off with a quote from Josh Lovejoy from the Google UX team, illustrating the importance of user research. So I know most of us are technologists here, and we love technology so much. We are very much prone to focus on systems and algorithms first and put user needs only second. But the risk is that we develop technologies that do not address actual problems or will actually have any users in the end. And keep in mind that AI is not quite ready yet today to be able to figure out for us what problems we actually should be solving. Now, having said that, a word of caution here too, but if we were only a user-centric hat and only focus on what users desire and envision a beautiful future, we might also end up with failure, as there are many cases in which the underlying technology were not mature enough or good enough to support a compelling use case, such as, for instance, Microsoft Clippy. New technologies and breakthroughs, as depicted here in AI, they can potentially, of course, also lead to novel disruptive user experience. However, as I hinted in the quote, if we do not take user needs into account, they're also at risk of failure. One such example is Google Glass, which initially failed because of people's privacy concerns. So ideally, we would want to close this loop so both sides can be calibrated as user needs are shaping AI systems and AI technologies influence the user experience. Among many other examples, Face ID on your phone is one great example for a successful integration of AI into our day-to-day life by combining a user-centric design approach with the availability of novel enabling machine learning technologies. And as you can probably imagine by now, on my own team, we care deeply about applying this human-centered approach to the AI development process across as many projects as possible. We're always trying to balance user needs with cool technology advances, and our work comes in different forms. So this includes conducting studies and publishing those results at academic conferences like CHI or NeurIPS. But we're also building deployed systems that you can go and try out later, or we are open sourcing our development work through toolkits around a common theme, like, for example, explainability. That's something you heard a little bit earlier, a really important concept. And what we learn through developing and studying these systems, so my job, our job is we need to inform the larger IBM product portfolio. That's why we are here in research. And if you look at the titles of some of our recent publications, for example, at CHI, ICAPS, IUI, NeurIPS, CCW, so those are the venues where we publish, you will notice that automation through AI and human AI collaboration are really important themes for us. But if you think about that, ultimately, what's currently in our mind on automation and human AI collaboration feeds into a much broader perspective, and that is actually on understanding how to effectively integrate AI into the workflow of enterprise users. And keep in mind here that when we talk about automation, we mean infusing AI into systems that help humans complete tasks. So there's also, of course, automation that can be done without AI, and that has been around for a long time. But today, many tasks that could previously only be done by humans can now be automated through AI. So that's important to keep in mind. So with this point of view, I would like to take a look at the various levels of automation and frame the research that I'm presenting here in the context of these levels of automation versus the opportunities for true human-AI collaboration. And here on this chart, I've borrowed a 5-level spectrum of automation from our recent Kai submission that ranges from no automation on the left side on this slide to human-directed, system-directed, and full automation on the right side. This is, of course, a continuous spectrum, and other approaches and dimensions of labeling the degrees of automation have been proposed. For example, Eric Horvitz's principles of mixed initiative user interfaces can also provide a valuable guide from the perspective of how much initiative humans take versus the AI system. So in addition to that, I've added a y-axis here that reflects the degree of collaboration between a human and the AI system. So now, if you have no automation naturally, right, there will be no opportunities for humans to collaborate with an AI system. And likewise, if you have full automation and the AI runs the show by itself, there will be no opportunities for human-AI collaboration either. So quite obviously, right, there are increasing opportunities in between those 2 points, and it doesn't necessarily have to look like that very well-balanced curve here. But there's opportunities in between to design and build AI systems that collaborate with humans at various degrees of interaction. And we make the assumption here that the true value of human-AI collaboration unfolds somewhere here in the center, right, where the AI system becomes a teammate or an equal partner to the human, which means both sides show an equal amount of initiative, and the two of them together can accomplish more than each one separately. So one could make the argument that for an AI system to be an equal partner, the AI system will need to be able to mimic or have human-like intelligence or characteristics. So what we're really talking about here is artificial general intelligence, which entails that an AI system would be able to have human-like capabilities such as learning, general problem solving, reasoning, planning, goal-orientedness, creativity, critical thinking, natural language communication, and so on, just to mention a few. However, while we in research have made tremendous progress in some of these areas, if you think about it today, most of the AI systems we design and build fall under what we commonly call artificial narrow intelligence. That is, they are narrowly focused on a single task, they're domain specific, and they solve very specialized problems. And it's also noteworthy that while we use this term human-AI collaboration today, and my team is guilty as charged, as you have seen in all the paper titles that I showed you earlier, the AI systems being designed and built today are certainly more on the left side, and they're human-directed, and they're mostly augmenting human capabilities. And this also holds true for most of the human-centered AI research and development we do on my team. It's focused on systems that solve specialized problems and help human workers be more effective. However, we have also made forays into research areas that foster our understanding of true human-AI collaboration, in particular in the areas of communication between humans and AI and implications for collaboration, as well as computational creativity. Under specialized problem solving, we've worked on making data scientists more effective by automating some of their tasks. So this is probably highly relevant to the day today and to these presentations today. We've started looking into applying AI also to process automation. We've also looked into aspects of communication that will be relevant to consider when designing effective human-AI partnerships, such as social perception, mental models, cognitive bias, and explainability. And some of our more recent work focuses on computational creativity, and in particular how deep generative models may change how humans will collaborate with AI when it comes to creating physical or virtual artifacts. So we've started doing research in 2 domains here, drug discovery and software engineering, and I will give you a glimpse of that later. So this is, of course, way too much to cover today for my talk. So I'll be focusing mostly on the top area here and on the bottom area, illustrating how we're making some progress towards this notion of human AI collaboration. So let's start with the first one, and how AI augments the work of data scientists and tackles business process automation. So some of these things are probably very familiar to you. Data scientists are in high demand, and that demand is only going to increase. According to the US Bureau of Labor Statistics, there's going to be a 28% increase through 2026. So at the same time, I took this from this InfoWorld article, there's this 80-20 dilemma, which means while data scientists are highly qualified subject matter experts, they do spend 80% of their time finding, cleaning, and organizing data. Now, of course, this is an important activity because the models are only as good as the data. However, given how scarce data scientists are and the fact that they only spend 20% of their time on analysis, this seems like an excellent opportunity to augment data scientist capabilities through AI automation. So you have seen this also in an earlier presentation. To support this kind of automation, there are already a number of products and systems available in the market. So I haven't listed the one that you saw earlier, but there's IBM's AutoAI, there's Google's AutoML, there's H2O, Data Robot, or Auto Scikit-learn. And on the right-hand side, you can see two screenshots of IBM's product AutoAI. Integrated into Watson Studio. So I originally wanted to show you a quick video about this, but without the audio, I'm just gonna walk you a little bit through these slides. So the top screenshot shows you the first step, which mostly consists of uploading a data set and telling the system which column to predict, which also determines the type of prediction. In this example, we are looking at the Kaggle adult income KNN data set with two classes to predict. After pressing Run Experiment, the system explores a search space consisting of various transformers, feature selectors, models with multiple hyperparameters. And the second screenshot on the bottom shows you a visual representation of the progress. And I apologize if this is a little bit tiny, but it's also not so important that you see every detail. You can certainly try and play with that system too yourself after this presentation. So the second screenshot shows you a visual representation of the progress in the tree diagram, and it's updated as the system explores various alternatives. And underneath it shows the current leaderboard, so leaderboard of the models, that is, by the metric used. In this case, it's the area under the curve. And what we did is we ran an experiment with 30 data scientists to understand the productivity gains of automation in this space. And in this experiment, we were comparing the use of more traditional notebook approach and manually creating models versus AutoAI to solve a machine learning modeling problem. And the outcome was pretty compelling, probably not surprising to you in this case, but still compelling. So in the AutoAI condition, data scientists did produce more models. Compared to the manual condition 8 versus 3, they were able to generate models faster, 3 times faster than in the notebook condition, and the models also had higher accuracy and the data scientists made significantly less mistakes. Maybe not all that surprising, but what's really interesting about the study is, though, that the manual group with the notebooks, they had an unfaltering trust in the models they created, with that trust being significantly higher than the group in the AutoAI condition, despite the fact that the models that were auto-generated were actually better. The system used in the study also had a code generation feature that allowed data scientists to inspect and manipulate the auto-generated machine learning code. And most of the subjects in the AutoAI condition made use of that feature because they didn't trust what the machine generated and they wanted to see the code. They did report to us that they really appreciated the availability of that feature. And we did measure trust, and before and after the experiment, and in the AutoAI condition, trust significantly increased after the experiment due to the availability of a transparency feature. And so what the study shows you is that establishing trust in automated systems is really critical for adoption. And it's not always trivial to achieve, because you really need to know what to do in order to establish that trust. So when looking at the entire AI development lifecycle, and there's certainly different ways of chopping this down, preparing data, engineering features, and model building, they're really important steps. And while our core AutoAI research so far has focused on those, There are many other steps that are critical for successfully implementing AI systems in an organization, such as, for example, requirements gathering, data acquisition, model deployment, runtime monitoring, model refinement, and then, of course, decision making and optimization. So as a matter of fact, if you think about it, end-to-end data science is a very collaborative process involving many players in different roles. So we have expert data scientists, domain experts, operations people, and so on. So we administered a survey to 239 people in these roles along the life cycle to better understand their attitudes towards automation, challenges they see for automation, and understand also novel opportunities for us to augment data science with AI. So this chart here on the right-hand side compares the current level of automation. These are the top bars with the preferred level of automation, and my screen went somewhere else. There you go. Okay. So the bottom bars here are the preferred. Can you still see my screen? I don't know. I don't see a.
Yes, we do.
Okay, because there used to be a red frame around it, and that seems to have gone. Good, thank you. So the bottom bars are the preferred levels of automation by our respondents, and then L0 means no automation, that's the dark blue, and L4 means full automation, that's the yellow. So there's two interesting takeaways from this data. So across the board, on average, all our participants feel like there is still not enough automation today. So the good news is they want more, meaning we have more work to do here. We can also see in this chart that participants overwhelmingly do not want full automation across the stages, but rather an L2 level, which is right in the middle of our automation chart, where we see human AI collaboration, which is a balanced mix between human-directed and system-directed interactions. And leading opportunities here for automation are in data pre-processing, feature engineering, model building, model deployment, monitoring, and refinement. And there's also areas where people do not want a lot of automation, such as, for example, in the requirements gathering, model verification, and decision optimization, which seem areas where humans are still doing a really, really good job. So I mentioned earlier to you that trust is very important for AutoAI. So when we asked our subjects about different types of explainability that could help establish trust, for example, what, how, why, and what if questions and confidence values, they overwhelmingly rated most of them as very or extremely important across all the stages of the life cycle, which can be seen in the top chart here on the right-hand side. But more interesting, in a separate study with 21 data scientists, where we focused only on trust, they ranked a list of transparency features that they considered really important. And you can see an excerpt from that list on the right-hand side that just shows you the top 13 features from that list. But what you can see there is, aside from displaying performance metrics as the #1 item here, there's visualizations seem to play a very important role in increasing this kind of transparency, like visualizing model performance here, visualizing column distributions, visualizing raw data. You get the idea. There's a lot of like visualize and visual and view in that list of what people were desiring here. And just to give you a glimpse, we have started exploring data visualization features as part of the AutoAI systems. And in this viz shown here on this slide, we enhance the visualization technique of parallel coordinates by allowing our users to drill in and explore elements of this pipeline further. So we call this technique conditional parallel coordinates. And this is also presented on top of the model leaderboard. And this visualization allows data scientists to inspect and also interact, not only see, with the various stages of the pipeline in detail, while at the same time not losing the overall big picture. In a small user study, we were able to show that this visualization can increase understandability of the process significantly. We've also started augmenting other stages of the development lifecycle with AI capabilities. For example, during data acquisition, the availability of labeled data is often a major impediment to successful enterprise AI. Many use cases there do require subject matter experts for labeling. For example, when building models for intent classification in conversational systems, we heard this earlier in the banking example, that the chatbots are Not really where we would like them to be quite yet. But this is one important activity that that is being done as part of building chatbots. And the screenshot on the right-hand side shows you a case in which users had to label utterances, selecting from multiple labels on the right-hand side. So subject matter experts are expensive and they are often time constrained. So this is also an interesting area for us where AI assistance could potentially make a difference. So we tested this hypothesis with 54 users in a between subject experiment in which we administered assistance through weak AI, which was trained on less samples, versus strong AI, trained on more samples. So this was sort of like a label recommender system that we built here. And you can see AI alone without human involvement achieved 44% on weak AI and 59% on stronger AI accuracy. However, what's really interesting and why I brought up this example here is when combining human with AI assistance, we can achieve up to 79% accuracy, which is a great example how the combination of human plus AI is better than either side alone. And if you're interested in this work, I've also left a reference on the bottom here. This is a paper that was just presented at IUI in April last month, and then you can understand a little better the details of this user study. So let me conclude this first part of the talk by giving you one last example outside data science where we are augmenting human capabilities through AI. So recent industry success on robotic process automation, you might have heard the term RPA, they have moved the area of business process management also into the focus of AI. And there are tremendous opportunities for AI automation here. For example, in a recent side-by-side comparison, we tested our own AI Ops tool. The AI Ops tool we have as a product in the market is an AI-powered process automation tool that helps with IT incident management. So managing your IT infrastructure. The tool applies machine learning and AI techniques to massive amounts of log files that these IT management systems produce. And AI is being used to rapidly identify incidents and suggest and recommend ways to resolve these incidents. In a comparative study, researchers were able, was not done by my own team, but other researchers were able to show that incidents can be resolved significantly faster with less steps, requiring less people at a fraction of the cost. And again, if you're interested in learning more about AI Ops, I've left a reference below to a keynote Rama Akiraju gave at BPM 2020. Now you can imagine if you think about a system like this, that like AI Ops, that it consists of many components that solve different AI and non-AI problems to accomplish a task. So I've been thinking about how to generalize the use of AI for process automation, making it more domain independent and also making it available to non-subject matter experts. So in some of our case studies with customers, we identified that natural language interfaces would lower the barrier of entry for non-subject matter experts into process automation systems. So just to give you a glimpse, this is ongoing work, by no means finished, so we're just starting off. So in order to generalize AI-infused process automation to more domains, we've started exploring more flexible systems that support the composition of process automation applications based on multiple agents and natural language integration. So in these multi-agent assistants, how we call them, we envision human and digital workers to collaborate together to accomplish a task. And at the heart of this idea is an intelligent orchestration layer that decides which agent to invoke at which step in the process based on user and system events. To the end user, for example, a loan officer, as illustrated in this chat above, this orchestration is typically invisible. So in the short example above, the PDF document that's posted to the chat is processed by a content analysis agent, whereas the loan decision is managed by an agent that is able to make rule-based decisions for loans given the right parameters. And these agents are artificial agents and not human agents, just to clarify this. So if you're interested in learning more about this AI platform for process integrations, I've included a reference below, also of a BPM 2020 paper that describes this use case in more detail. And you can imagine that given the conversational interface that we envision here, that this system also provides an excellent playground for us to experiment with human AI collaboration. So let's move to the second half of my talk. And as AI systems become more powerful, they will be able eventually to mimic or even possess traits that define human intelligence, such as, for example, creativity. So I want to talk a little bit about this computational creativity area, which is something that we have started looking into. And we started looking into this domain because it has tremendous potential for our future in general, and offers new opportunities for designing true human AI collaboration systems. And in this context, this kind of collaboration between humans and AI is also often referred to as human AI co-creativity or co-creation. So if you read up literature about that, you will often find these terms. And it basically means humans and AI systems working together to create physical and virtual artifacts. So this is not about decision making like in discriminative AI systems. So let me jump into this. So while this field of computational creativity has been around for a while, as you all know, a powerful new class of deep learning models, which are generative, has gained tremendous traction in the past few years and has led to breakthroughs in AI-assisted content creation. And while you're certainly very familiar with Ian Goodfellow's work on GANs and how they can be used to generate photorealistic images of fake people, these algorithms are increasingly used in industrial settings with very impressive results. For example, Airbus designed a new compartment divider for the A320 that used less material and increased maximum load capacity, reducing CO2 emissions. Airbnb developed a sketch-based user interface design tool that enables designers to test UX designs faster by translating sketches into code. And in our lab here at IBM Research, we were able to demonstrate a path for the discovery of antimicrobial peptides, reducing the drug discovery time from 2 to 4 years to 48 days with 10 times higher success rates. The band Yard created their album Chain Tripping with generative AI, and it was nominated for a Grammy, which demonstrated inspirational and aesthetic properties of these algorithms. So we are indeed at a point today where we have reached what Douglas Eck calls fluency in a recent keynote at one of our workshops, which means we can build good generative models. However, while we may have fluency, the production process of these models is really hard work still. It's trial and error often, and overall it's very brittle. It involves manually creating, testing, and iterating over multiple models, running batch script, combining results, and so on and so on. The algorithms, they typically lack an understanding of the intent of the creative producer. Most of them are feed forward, which makes it very hard to allow for control and steering the output in desired direction based on the human input. These algorithms also often produce way too many candidates, making it difficult to choose from, so there's an information overload. We need to address motivation of the subject matter experts to use these systems. For example, they might feel a loss of ownership all of a sudden because an AI system creates content for them. The interesting question overall for us really is, how can we make these systems accessible and usable for subject matter experts or domain experts? How do we design an effective co-creative user experience in which the role of the human changes more towards specification, steering, goal setting, higher level creativity, and intuition, whereas the AI can provide inspiration, low-level creativity, and detail work, or generate variations that improve quality and speed. So this all sounds maybe a little bit abstract, so I want to give you a very simple example to illustrate this notion, of course not in full force. I wish I could show you a video of this, but I'll try to do my best to explain this to you. So this is GANPaint. This is a painting tool we developed together with MIT. It's a pretty cool painting tool because in this tool you don't paint by manipulating pixels, but rather with neurons by manipulating the latent space. So in the UI, you can select objects such as trees, doors, grass, sky, cloud, and just decide where you want to place these objects. And you don't need to put exact locations. You can just roughly annotate where you want these objects. For example, I've added 2 trees here to this cathedral on the right-hand side in Sardinia, to the left and the right of the cathedral, and they perfectly blend into the cathedral. So if I added doors to the building, the model would exactly know the right proportions, merge them nicely into the existing image, adjust the colors. You don't have to do any of this manually because the model has learned the properties of those objects, because the model has learned on millions of data points with unsupervised learning. The interesting thing here to note is that if I try to add a door to the sky, the model would not allow me to do that because it has learned that doors typically cannot be found in skies. And that's the reason why I brought up this example, because it's a good example of how this kind of interaction with a generative model is not only human directed, but also has aspects of system direction, because the system has an understanding and has a representation of the world, and you have to interact with the system with that given representation of the world, which poses all sorts of challenges and opportunities. I've left you a URL at the bottom of this slide so you can play with GANPaint yourself. The website also has a nice 2-minute video that shows you a little bit more of the technologies that are being used behind and the algorithms. So we've recently started experimenting with co-creation generative systems in business domains. For example, we've developed an interactive user experience that allows computational chemists to explore the latent space of generative models for peptides with antimicrobial properties. If you don't know what that is, this is to overcome antibiotic resistance. We do this here by interpolating between 2 known good peptides, actually in the user experience, with the hope that if you walk the path between 2 known good peptides, that you will find other peptides with similar good properties. So each peptide in the screenshot on the right-hand side is represented as a sequence of characters. So we're using language models here. And we're showing various properties of these peptides, so a chemist can examine them as well as the 3D structure, using their intuition and knowledge to further narrow down the selection that the generative model has made. And just to let you know, some of the peptides that came out of this work, they were actually synthesized for real and tested, and we found some of them that are actually really working in the real world, and this is being further pursued. There's a very similar work that you can see on the IBM website on drug discovery for COVID. We also have a COVID Explorer. I don't have a screenshot here, but if you just go to ibm.com and look at IBM's response to COVID, you will find that work there, which was done by the same people. Another domain we're looking into currently is applying generative models to the various tasks software engineers perform, such as coding, documentation, or testing. So in this experiment here, we explored the user experience of assisting software engineers with code translation from Java to Python. The envisioned use case here is application modernization. That means bringing legacy applications onto a new platform and into a new programming language. This is a very time-consuming and tedious task and expensive. So here we used the neural translation model from Lachaud et al. From 2020, and we conducted a design probe with 11 participants through semi-structured interviews to understand their attitudes towards automated code generation, as well as get feedback on the user experiences we designed. Just to give you an example of these user experiences, they look very much like developer user experience. So the user experience B shows the transcoder translation plus confidence highlighting, where the model was less confident in the translation, and user experience C shows the transcoder translation, confidence, and alternate translations. And of course, we collected detailed feedback on that, but I want to jump over these details today because there were also a few interesting findings in the study that I like to highlight here in the context of co-creation. So similar to AutoAI, which I presented earlier, trust came up as an issue. However, in contrast to AutoAI, our participants were not really interested in understanding how the model functioned under the hood and how the model came to make decisions. They argued that trust should be established in a similar fashion as if the AI were a team member by verifying the work through code reviews. So this is interesting. And similar to a human peer who they would give feedback during code review, our participants raised the expectation that an AI system needs to learn from the feedback they provide, so it would become better at its job in the future, almost like teaching a junior software engineer. Interestingly, we also observed a high tolerance towards mistakes made by the model as long as the generated code saved them time. They expressed willingness to review and improve upon it. Beyond code translation, our participants also came up with other areas where they envisioned AI could help them generate code, for example, for creating higher level structural system code, so they could get a head start on building a novel system from the ground up. So this wasn't the original use case, but this is interesting since this illustrates how the role of the AI system changes more and more in becoming a creative partner rather than being a mere translator, like in this example. So the work here is just scratching the surface. As you can imagine, this is a very exciting domain for me. It offers a lot of opportunities to explore this notion of human AI collaboration. If you're interested in this, I'd like to point you to 2 workshops on this topic. So the first one just took place at IUI in April last month. It was organized by Lydia Chilton, Mary Maher from UNC, Justin Weitz, and myself. This was a workshop on human AI co-creation. Proceedings will come out soon, hopefully, on CEUR. So check the website if you're interested in reading up on those papers. And we also had 2 very interesting keynotes there. The other workshop on machine learning for creativity and design takes place annually at NeurIPS. So this is coming up in December and focuses a bit more on the artistic and design side of generative models. All right, so slowly coming to an end here. I have a few more slides. So today in my talk, I've proposed to you a human-centric approach to the development of AI systems, taking both user needs and technological capabilities into account. I've given you a number of examples from our research portfolio that demonstrated how AI can be effectively integrated into workflows to increase productivity and effectiveness in very specialized domains. And what came up here as a very important aspect is that challenges of trust and transparency need to be addressed because they can impact adoption. As our work is shifting more and more into exploring this notion of human AI collaboration that I outlined in this center of the 2 bubbles here between no and full automation, I've given you a glimpse of our exciting work around human AI co-creation with generative models. Of course, we are continuing to explore that space. In particular, we are working on conceptual models of human AI collaboration that help us develop a theory and drive research and user studies. For example, we looked at the Shannon-Weaver model of communication developed back in the late 1940s. This model assumes an information source, a recipient, along with a channel for transmitting between them. And as information is encoded by the sender and decoded by the receiver, this model allows us to explore aspects of explainability, for example, mental models, social perception, or cognitive bias from both sides, sender and receiver, and how those affect knowledge creation, sense making, and decision making. We did some research on this. I didn't have the time today to go into this, so this would be for another day. We also know tons about human-to-human collaboration, but there's quite some work that still needs to be done to understand how these past findings, for example, from the CSCW communities or computer-mediated communication communities, how they translate into human AI collaboration. So I also wanted to give you some pointers to additional resources. Our team developed AI explainability design guidelines that are available online. There's a URL at the bottom that will bring you to those. Major players in the space, such as IBM, Google, Microsoft, have developed interesting and valuable design guidelines too. Some of the research we do, they actually feed into the IBM design guidelines. So these are all really, really interesting and valuable to study when building AI systems. And then as part of our trusted AI agenda, we are making a few toolkits and resources available online. For example, there's AI fact sheets. The problem of governance came up earlier in one of the talks. So fact sheets is a system that helps you with governing AI development across the entire life cycle. We have an AI explainability toolkit AI fairness, and also the adversarial robustness toolkit. And some of these toolkits have APIs and open source and code that you can play with and explore. So in closing this, our research indicates that human workers desire more automation than they have today, but they do not want full automation. They prefer a partnership with an AI system. The studies we shared with you today, they shed some light on the challenges in designing this collaborative partnership. And now if you think about moving beyond the sweet spot in the center, right, more towards full automation where systems are more directed by AI than by humans, it does not necessarily mean evil AI systems are taking over the world and humans have no more control. So we see actually opportunities for human AI collaboration along the entire continuum of automation. They will just take a different form. And just one thing here that's also important for me to say, the more you are on the right side here of the spectrum, right, that's where I drew this bubble on the right side, the more the term human in the loop, and you might have heard this before, will be an accurate description of that relationship because the humans will not be gone. But unfortunately, this is a term that is really broadly used today when people talk about human-directed AI systems, because systems today are more directed and not human in the loop. So with that thought in mind, and I'm almost at the end of my time too, with that thought in mind, let me close with a quote from Tom Malone, which is very much in the spirit of my talk today. A lot of time today is spent on thinking about AI versus human, as if this was a competition or a battle. But I think we should really think more about how to design an effective partnership between humans and AI systems. So thank you very much for attending my virtual talk here at BFU, and thanks for having me. I hope you enjoyed it, and I'm looking forward connecting with you on Twitter or elsewhere or on LinkedIn. So stay healthy and safe, and maybe we have some time for questions, or maybe it's weekend already. Thank you.